Okay, I think we can start. Good evening, good afternoon, good morning, based on wherever you are. Thank you for joining this workshop on fsQCA for quantitative research and quantitative data analysis. Hope all of you can see my screen and my slide, right?
Yes.
Okay. So this workshop is a part of the 2021 JHTM Online Research Symposium and Paper Hackathon. And the topic of this workshop that I will try to cover in this 1 hour time is about using fuzzy set qualitative comparative analysis in quantitative research. So I'm a bit of introduction of myself. I'm Dr. Mustafa Rasuli Manesh. I'm associate professor in the School of Tourism, Hospitality and Event, and the director of Center for Research and Innovation in Tourism, CRIT, and the head of research for the Faculty of Social Sciences and Leisure Management, Taylor's University. My area of interest is sustainable tourism, heritage tourism, community participation and tourism, and urban sustainability. Also, one of my favorite topics to work is application of quantitative approach and quantitative, especially quantitative data analysis, advanced quantitative data analysis in social science discipline. So I published more than 100 articles in reference journals, including some high impact journals. And now at the moment, I'm editorial board of several reputed tourism and hospitality journals, and also associate editor for Journal of Hospitality and Tourism Management, that now we have this research symposium under this journal, and also associate editor for Journal of Hospitality and Tourism Technology, Journal of Hospitality and Tourism Insight, and regional editor Asia and Asia Pacific for the Service Industries Journal and the International Journal of Tourism Policy. In this workshop, actually, I will try to cover some topic based on our time related to fsQCA. And my main source for discussion today will be this paper that we recently published in International Journal of Contemporary Hospitality Management with three great scholars, Professor Christian Ringle and Professor Marco Zarset. These two persons are great scholars in the area of PLS-SEM. So, and Dr. Hossein Olia, my close friend, and actually, in this paper, we discuss some basic component of fsQCA and the combination of fsQCA and PLS, how we can combine a result of PLS and fsQCA. If we have time, I will try to, at the end of this workshop, I will try to go through this combination as well and see how we can combine and how PLS and fsQCA can be connected. I will try to cover this topic in this workshop as much as I can. I will provide some history and definition of fsQCA, the meaning of some basic and important steps for performing fsQCA, like membership and calibration, truth table, consistency and coverage, and necessary or necessity condition analysis, XY plot, predictive power, if we have time, one example, and at the end, very, very briefly about PLS-SEM and fsQCA. Okay, first about definition and history. This QCA, now I don't say fsQCA. Later in short while I will explain why at the beginning we don't say fsQCA, because actually the fsQCA is for, we have different types of QCA. So we need to understand the basic concept of the QCA first. So qualitative comparative analysis, or QCA, was developed by Rajin 1987. But mostly for political science and the historical sociology, as a macro comparative approach for complex situation and also for small sample. So if you look at, because if you look at also title, you can see qualitative comparative analysis, and you know in qualitative work we don't work with qualitative research, we don't work with the large sample size. We work always with the small sample, right? So this method originally was developed for small sample and for qualitative work. But later, this method actually was extended to quantitative by application of larger sample size and larger data set. So in this actually method that I mentioned, developed by Rajin in 1987, we try to analyze complicated causation and complicated causal relationship between social phenomena. We call this combination of variable, combination of factor that involve in causal relationship, we call recipe or causal combination or configuration. So we have different names for this relationship in QCA. In tourism and hospitality, actually, the application of the fsQCA and QCA was started quite later. And if I'm not mistaken, first papers actually apply this method, if I'm not mistaken, in tourism and hospitality. In other discipline, we actually started application of this method earlier, but in tourism and hospitality, if I'm not mistaken, the first paper published by using this method, published by my good friend, Dr. Hossein Olia. But we can see good number of papers published in recent years. Here I put a few papers from tourism and hospitality disciplines, and you can see different topics like travelers' willingness to pay, tourism accommodation service, festival management, tourism behavior, peer-to-peer accommodation, medical tourism, tourism experience and engagement. Started to apply this method in recent years. But before going to definition, very briefly say about my story. Actually, my area is sustainable tourism, resident perception, and tourism development. And this area, you know, is a complex situation that when we investigate this area, we face with the complex situation, involvement of different factors and different stakeholders. From 2018, I was started to think about this method after I saw a few papers published using this method. And I started to read and try to start to use software and perform analysis and strengthen my understanding, deepen my understanding about this method. And later I came to this point that this method can be combined with some of the current advanced method in quantitative research. We have many papers that combine SEM, structural equation modeling, and fsQCA, but because of one main reason that I will explain hopefully at the end of this session and workshop. We believe, I say we because we were working together on this idea and topic, and finally we published in International Journal of Contemporary Hospitality Management. This link is not clear link between fsQCA and SEM. So we concluded that we need to come out with a new idea and see how we can link these two advanced topic to get a deeper result from our quantitative data. So let me start with some basic definition of QCA. I try to explain in a simple way that all of us understand together, and also this is very good learning opportunity for me. And later we have a discussion, and through your question I can learn more about this topic, because I think there are big opportunity for application of this method in tourism and hospitality, and in general in different social science disciplines, and we can get really more comprehensive result if we combine this method with the current quantitative data analysis method. So let me explain in some basic of this method. When we apply QCA, actually we try to identify sufficient and necessary condition to predict an outcome. For example, if we have three independent variables, three predictors, X, W, and Z, and we want to see the effect of these three predictors on Y, QCA help us. And when we perform QCA, we are able to identify sufficient combination of these three predictors to generate high level of outcome. For example, if we have three IV, our three IV are salary, bonus, and promotion. And we want to see effect of these three variables on job satisfaction. So when we go to our respondent, in case one, we get this answer. If salary, X variable, the level of salary is high, and there is good condition for promotion, I'm satisfied with my job in this company. So first respondent say, okay, X salary and Z promotion are two important factors for me to be satisfied. But when we go to second respondent, we see second respondent answer and indicated salary X and bonus W as important factor to be satisfied. So second respondent answer, if my salary is high and bonus is high, I don't care about promotion, so I will be satisfied. So here you can see, when we go case by case, we can see different conditions for high level of satisfaction, right? So we can say if X and W happen together, what we can get from this case number one and case number two, if X and W, for case number one, if X and Z happen together, respondent employee will be satisfied. And second, if X and W happen together, so our employee will be satisfied. So we can conclude that X and W together or X and Z together can be sufficient condition to lead to satisfaction, to lead to job satisfaction, right? So this condition, this combination of predictors that lead to high level of outcome and can generate high level of outcome can be called causal recipe configuration or causal combination of factors, predictors that create a high level of outcome. Sometimes this can lead to understand and identify some necessary condition. For example, if you have 10 cases and among 10 cases, we can see X has been repeated for all cases. So we can understand that variable X, predictor X, is necessary condition for all situation, condition, combination of predictor to reach to high level of outcome, right? For example, here, if you look at this in this table, we have only 10 cases in this table, right? In case number 1, you can see case number 1, satisfaction of case number 1 depends on 3 factors. 1, depends on bonus, salary, and promotion. So 3 factors should be high to satisfy case number 1. But in case number 2, only bonus and salary is sufficient. Case number 3, salary and promotion can be sufficient together to satisfy this person. Case number 4, bonus and salary. Case number 5 is very interesting case. If only one variable, if only salary of this person is high, so this person will be satisfied and don't care about other 2 factors. So here you can see different combination of variable that can lead to high level of satisfaction. So here you can see 2 things. 1, case-based analysis. So you can see in this type of analysis, we do analyze based on each case. So QCA can be considered as a case-based analysis. Second thing, you can see heterogeneity among all respondents. Satisfaction of all respondents is not similar, is not same. Depends on different combination of factors. 1, satisfied when 3 factors are high, but case number 5 can be satisfied if only salary is high, right? So you can see in this case-based analysis, we can identify different sufficient conditions to create high level of job satisfaction. For different condition, actually we can have different situation. For W, for salary, if we look at this table, only for these 10 cases, W, salary, repeated in all cases with high level of job satisfaction. In these 2 cases, we have low level of job satisfaction. But for all high level of satisfaction for 8 cases, you can see W is one of the factors. So when one factor include in all sufficient condition, all sufficient combination, it means we have to consider these condition as this variable as a necessary condition to generate satisfaction. So W in this 10th case is sufficient, is necessary. Also is sufficient. For case number 5, you can see W alone, salary alone, can create high level of job satisfaction. So W can be sufficient and necessary condition. But some conditions like X, W, Z together, or only X and W, W and Z, X and W, right? W and Z, these conditions are only sufficient condition, not necessary, right? So they can stand alone and create sufficient evidence. They are sufficient condition to generate high level of outcome, high level of satisfaction, but they are not necessary because they are not repeated in all different conditions. Another things that can be one of the situation, for example, if we remove case number 5, so we only have 5 different cases. We can see W repeated in all cases, but when we remove this case, W cannot be sufficient condition, but is necessary condition because it is repeated in all different cases when we remove this case. So for others, we have W in all cases, in all conditions, but not alone, right? So this case can be, this condition can be considered necessary, but not sufficient. Also, we have this situation, insufficient, unnecessary. There are many cases, many conditions that they are neither necessary nor sufficient. So, for example, this case X and Z, right? X and Z, bonus or salary or promotion, cannot be a necessary condition and also cannot generate a high level of job satisfaction. So they are not sufficient condition. So in QCA, we identify sufficient and necessary combination of predictor to generate high level of outcome. This is basic and foundation for understanding QCA, a qualitative comparative analysis, and later this is foundation also for fsQCA. I will explain why we go to fsQCA. Here there are some examples of some papers published in tourism recently. This is one paper published in 2020. So in this paper, we can see 4 independent variables that influence intention to use peer-to-peer accommodation. So here we have economic benefits, social interaction, sustainability, and social esteem that influence intention to use P2P. But when we apply conventional method, for example, we apply SEM, what we can get? Only we can get the average of this variable for all our respondents. And based on this, when we have regression-based analysis, we can identify beta coefficient, path coefficient for each variable. So we can see the effect of which one is more important and which one is significant, which one is insignificant, right? Only we can get this information from a regression-based analysis, including all SEM analysis. But if we apply QCA, what we can get? We can have combination of social interaction and economic benefit that create intention to use. Also, we can have combination of social esteem, sustainability, and social interaction. We can have combination of economic benefits, social interaction, sustainability. So we can monitor and we can identify different combinations that lead to high level of intention to use P2P, right? Another example here, airport service. Effect of airport service, different dimensions of airport service and the different predictor to passenger satisfaction and revisit intention. If we apply regression-based analysis, we can see, at the end, we can say the effect of layout, checking, security, ambience, facility, which one is significant and the effect of which one is more important, right? And which one is not significant. But if we apply fsQCA, we can identify different combination of these factors. For example, in one combination can be layout, checking, security. If layout, checking, and security happen together, so passenger will be satisfied and there will be high level of revisit intention. If we have layout, technology, and personnel and facility, we will have high level of satisfaction and revisit intention. So we can identify heterogeneous combination of predictors to generate high level of outcome, right? This is another example. This is our paper that we published recently in Tourism Review. So here we have 8 dimensions of memorable tourism experience: hedonism, novelty, local culture, refreshment, meaningfulness, knowledge, and involvement. So we have these 8 dimensions that influence satisfaction, word of mouth intention, and revisit intention. If we apply, as we did in this study, PLS-SEM, only we can understand significant and insignificant effect of this dimension on these 3 factors and outcome. But if we apply fsQCA, we can find very heterogeneous and different combination of these dimensions that can generate high level of satisfaction, word of mouth, and revisit intention, right? So you can see in complex situation how fsQCA can help conventional method, regression-based method, to come out with deeper understanding of context and deeper understanding of situation. And of course, we can come out based on this result from fsQCA, we can come out with the deeper practical implication, a theoretical contribution, because we can identify different sufficient condition and also necessary condition to generate satisfaction and word of mouth and revisit intention. So based on this, we come to this point that when we have symmetrical and asymmetrical approach together, there are arguments that a symmetrical approach can be insufficient for analyzing complex situation, because only based on symmetrical approach, we can analyze only one combination of predictor. But actually in the reality, we have a symmetrical combination of a predictor, and we can come out with different combination, and all respondents are heterogeneous, right? So here we can see this comparison by Professor Woodside and on his paper for symmetrical approach and asymmetrical approach. In symmetrical approach, regression-based approach, we only can identify and draw one regression line, right? And then a regression equation. So we can identify beta coefficient for different variable. But in asymmetrical approach, we can identify actually different conditions that can generate high level of outcome. Here is another representation of this comparison. So in asymmetrical approach, you can find different combinations that lead to sufficient, can lead to high level of outcome. So these combinations can be sufficient to generate high level of outcome. But for symmetrical approach, regression-based approach, only we can see this equation, this regression equation. And in this regression equation, you can identify only that, okay, X is important or not, significant or not, and what's the level of the significance and importance of X, W, and Z. So you are not able to identify different combinations. But for asymmetrical, you are able to identify. But to perform a QCA and the fsQCA, actually, we need to do some steps. Without these steps, we are not able to perform QCA. First step actually for performing QCA is membership. We need to assign membership to all variable for each case. For assigning membership, actually, we assign the values between 0 to 1 to all variable. So the first step is assigning this variable that we call this assignment as calibration. Later, we will discuss about the different method for calibration. But this is an important step to perform QCA. For this value and this membership, the value of 0 is considered full non-membership. So it means if we assign 0 to a variable in case, it means the level of this variable for this case is lowest one. So there is no membership for this variable for this case, this respondent. And the value of 1 represents full membership, right? But we have different types of calibration and setting membership. Only here, I highlighted two main types of calibration that are actually the most important, and in the literature you can see focus on these two main types. One is crisp set QCA and one is fuzzy set QCA. For crisp set QCA, actually calibration is done only for two values. So we have a dichotomy. So we have a dichotomy if we apply crisp QCA or CSQCA. It means only we assign two values to our variable, 0 and 1. And 0 represent non-membership, while 1 represents full membership. But when we go to fuzzy, this is more qualitative. This is more qualitative and for dichotomous situation. But when we go to fuzzy set QCA or fsQCA, actually we calibrate our variable to different layers and different values. So we assign different values to represent, to show membership. So when we apply fsQCA and the fuzzy calibration, actually this can accommodate quantitative research, because in quantitative research, we have different type of variables. We have ordinal variable, we have continuous variable, right? So this can accommodate different type of variables. Here is a table that show different method for this calibration. You can see the first one is for crisp set. Only we have 1 and 0. 1 is fully in, 0 is fully out. But when we come to fuzzy, some literature also has one type between crisp and fuzzy. So they call multivariate set. But here I put based on Rajin, I put only for fuzzy, and consider also this ordinal variable 3, 5, and 7 point Likert scale as the fuzzy set and calibration under fuzzy set. So we have, if we have 3 values, so we can convert to and consider 1 as a fully membership, 0.5 neither fully or nor neither fully in or nor fully out, and the 0 is fully out and non-membership, right? But if we go to other level, okay, you can see more values and levels. 1 fully in, more in than out, crossover. Middle value we call also crossover, neither or nor in, neither out, nor out. And 0.25 in more out than in, and 0 is fully out. 7 again, and the final one that is can be considered perfect fuzzy set is for continuous variable. So for continuous variable, we have 1 for fully in, full membership, but between 0.5 is a crossover point. So it's neither in or out, but between 0.5 and 1, so the variable can be translated, can be converted to between 0.5 to 1. This is degree of membership, so it's more in than out. And between 0 and 0.5 can be considered degree of membership in more out than in. But also we can consider in these different category a degree of membership. So we can have membership in kind or difference in kind and membership in degree. Membership in kind is for crisp set. So only we have 2 values. But when we go to continuous, we have degree of membership. So we can have degree membership in degree. So we have different level of membership. So this is first step for performing QCA. So we need to convert our variable, our data set to this range 0 to 1 and calibrate our variable. This is first step. So based on this, we can analyze our data and we can identify high level and low level of predictor and the outcome to identify sufficient and necessary condition. Second step is the truth table. Truth table actually are all possible combination of predictors. So we have to identify all possible combination of predictor and then see which combination is sufficient, which combination is necessary, which one is insufficient. So we can calculate, we can identify the sufficiency of one combination of predictor to create to generate high level of outcome. So we, in this step, actually second step of fsQCA or QCA analysis, we have to create this truth table. So in this truth table, we identify all possible combination of predictor. Some of them lead to high level of outcome, and some of them lead to low level of outcome, right? So some of them can be sufficient and some of them not, right? And okay, to create this truth table, in first stage, if we have three variables, if we have three predictors, we can create at least 8 different combination of predictors. 8 different combination of predictors. In other words, we can, in truth table, we can create to the power of k rows or combination of predictors. K is number of predictor, number of independent variable. If we have 2, so we can create 4 different combination in first place. If K is 4 variable, 4 predictor, we can create 16 different combination of independent variable, possible combination. But actually, we also can combine these combination to generate more combination of predictor. So for this combination, we can use some Boolean operations. So, you know, Boolean algebra, here in QCA, we apply Boolean algebra. And you know, Boolean algebra is different with the traditional algebra. So when we apply this operation, in short while I'll show you, so the result will be different with the traditional algebra, right? Okay, we use 3 operations for combination of these 2 power of k combination and to generate new combinations. First one is negation. So that's shown by this symbol, and change membership by subtracting the fuzzy set value from 1. So for example, if the value of x is 0.2, so negation of x, the value of negation of x will be 1 minus 0.2, so will be 0.8. So this is one symbol that we use for creating new combination of predictors. Second one is AND operation, logical AND. So the symbol is this symbol, and the last one is logical OR, and the symbol is the plus symbol. And for AND, actually, when we combine 2 different situations with AND symbol, we select lowest or minimum fuzzy value. Minimum fuzzy value. Remember, don't forget, all fuzzy value, our membership is between 0 to 1. First step, we calibrate our variable. And now we have, based on this operation, we can generate new values. And for using logic OR, we can get maximum value of 2 fuzzy set. For example, here we have some example. For example, if we have A and B and use the logical AND, so A is 0.17 and B is 0.33. So A multiply B, right? This is multiplication. So this one, this will be minimum value of this tree. So it will be 0.1. So in Boolean algebra, it's different with traditional one. In traditional algebra, if we multiply two variables, 2 multiply 3, we will get 6. But in Boolean algebra, we can get 2 using AND operation. We get the minimum value. So 2 and 3 will be 2, right? And for OR, maximum value, so A plus B, or using OR, will be 0.33, and for negation will be 1 minus 0.17, so will be 0.83. So this is a truth table. There are some comments.
Professor, sorry to interrupt. If you could come to a conclusion in the 5 following minutes, so we have enough time for the questions. You already have a question.
5 minutes. So wow.
Thank you. We have enough questions for you already.
Okay,
so
okay. Let me speed up and just. Okay, truth table. We can combine this situation. One more thing that we need to step 3 that is important for combination for performing fsQCAs, calculating consistency and coverage. Of course, only one respondent, one case that represent one combination of predictor cannot be considered as a sufficient condition, right? So what's the threshold for number of cases to consider to conclude that is sufficient or necessary condition? So for this one, we have to calculate consistency and coverage. Consistency, what's the meaning of consistency? I use the meaning of fsQCA crisp set actually to understand the meaning of consistency and coverage, because it's much easier. But consistency actually in literature sometimes is considered identical with correlation, and coverage is identical with the R square, correlation value and R square. But what's the meaning? Consistency is the proportion of cases for a specific condition that generate high level of outcome. For example, if we have X and W and Z, that these for some cases have generated the value of 1, the high value of outcome. For some cases have generated low value of outcome. So this condition can be sufficient if we have consistency above 0.8, means 80% of cases with this specific combination should generate high level of outcome. So, for example, if we have 20 cases that generate represent this causal combination, but out of these 20, 17 of them lead to high level of outcome, so 0.85 can be consistency. But when we come to fuzzy, because we don't have only 0 and 1, and we have different values between 0 and 1, so this formula can calculate this consistency value, but understanding and concept is exactly same as fsQCA and crisp set. And the value of consistency should be higher than 0.8. But for coverage is a different story. For coverage, we have to calculate ratio of one specific combination lead to high level of outcome divided to all cases, all combinations lead to high level of outcome. For example, if we have 300 cases, but out of these 300 cases, 300 respondents, we have different combination. 200 of these respondent, different combination of predictor for 200 of this respondent led to high level of outcome. So we have 200 cases with high level of outcome with different combination of predictors, right? And for one specific combination, we have 50 cases that lead to high level of outcome. So 50 divided to 200 will be 0.25. So coverage will be 0.25, right? Here, and this is formula for fuzzy set, again, because in fuzzy set only we don't have 0 and 1. And the acceptable value for coverage is 0.2. So it means at least 20% of outcome in fuzzy set membership can be actually the value of this come from one specific combination of the predictor. Here is a table that I calculated the sum based on some value. Just I explained one, right? Here we have 300 cases, and 220 of these cases led to high level of outcome, and 80 cases led to low level of outcome, right? For example, for this combination, negation of X and W and Z, we have 5 negative outcome and 45 high level of outcome. So to calculate consistency, this 45 should be divided to 50 total number of this case, total number of this combination. So 45 divided to 50 is 0.9. So consistency is 0.9. But what about coverage? Coverage is 45 divided to 220, all high level of outcome cases. So is 0.204. So you can see for this combination, but is a very simplified version of calculating consistency and coverage, because in this 8 condition also can be combined and create new combination. But for this one, just to understand, consistency is 0.9 and coverage is 0.2. So this condition can be considered a sufficient condition for generating outcome. For necessary condition analysis, we need to get at least both consistency and coverage for a specific condition higher than 0.9, that we consider this as a necessary condition, right? Okay, I prepare some slot for plot and predictive power. I cannot go through. Only for software, we have different software. We have different package for Stata. We have package for R to perform QCA and fsQCA. But one of the most common use is this fsQCA 3.0 software that I'm using this one. And I know many people use this one that developed by Rajin 2070. And also I have here a few steps to perform analysis in a QCA. But of course, in software, we have no time to go through. But we actually wrote a chapter for advanced methodology book in tourism and hospitality that is edited by Professor Ziopoulos, myself, and Dr. Jahani. So this will be published next year by Emerald. So in this chapter, actually, we try to explain in detail and step by step how we can perform different analysis, different steps of analysis and fsQCA using fsQCA 3.0 software. And this is the last one for combination of PLS-SEM. Just one point. When we say combination of PLS-SEM, you can see this diagram in our paper. But for combination of PLS-SEM, what we actually contributed for first time is to get latent variable score from a PLS-SEM result and use this score for as an input for performing fsQCA. So this actually can link result of PLS-SEM and result of fsQCA, and also can reflect the theory that we develop framework in PLS-SEM, develop framework in our study using PLS-SEM, because you know in PLS-SEM is only one approach that we can generate, we can get latent variable score from model. But in covariance-based SEM actually is not possible, because in covariance-based SEM we have the score and value indeterminate C. So the value of construct cannot be one unique value, but in PLS can be. So we got the result of latent variable score and use for for fsQCA analysis. You can read the paper to see the detail of this, and this is some paper, this is some references, and okay, you can reach to my Facebook, email, and LinkedIn, and also you can watch my YouTube channel. So this video also will be available in my YouTube channel. Okay, sorry, it takes more time, but maybe we can continue a bit more than 1 hour, and to accommodate your question, answer your question. Okay, now I'm ready to answer question. Fanny, you read the question, or I should go through chat?
Yes, I can do this for you. Thank you so much for sharing your knowledge with us. So we have exceeded our time, but we have a few questions for you. It was so an interesting workshop. So let me start. The method will not work properly if there are a few predictors, 2 or 3. Is it true? One question.
Method can work with any number of predictor, but of course, when we have complex situation, method work better, because this method is for complex situation. When we have 3 predictor, so the number of combination will be much lower, but when we have more predictor, so we can identify more number of combinations and causal and configuration. Yes.
Great. Another one question, how many interview samples should be collecting for using fsQCA method?
Actually, fsQCA is developed for small sample. So even with the 10 respondent, we can use fsQCA, because actually this is in first place, this was a qualitative method. So can work with the very small sample, but also for quantitative can work very well. So with the large number of sample also we can apply this method.
Thank you. Can we use fsQCA for a research model that involves mediators or moderator?
Moderator, yes, because in moderator actually we can split our data. We can split our data, and based on 2 subsamples, we can run fsQCA for a model, and we can compare sufficient condition for from 2 different groups, 2 different subsamples. So can be a good application of fsQCA. Actually, in the paper that we published in 2021 in current issues in tourism, we compare, we perform fsQCA for 2 groups of people, male and female, and we compare. So it's possible to do. But from mediator actually is a bit tricky, and we cannot assess mediator for using fsQCA. Still we cannot, but we are working on this project with my friend Dr. Olia. So hopefully we can come out with some suggestion for assessment of mediator using fsQCA.
That would be great. in order to perform QCA of fsQCA, we must have at least IVS in order to have the heterogeneous for necessary and sufficient.
IVF means what?
IVS.
Independent variables.
Yeah, independent variable. Yes, of course. We to identify sufficient and necessary condition, we identify combination of IDs, right? So we identify combination of predictors. So we need to have the predictor and independent variables.
Excellent. I think we have one more question for you. Can we have higher order construct for the dependent variable?
Yes, doesn't matter lower order, first order, or higher order construct, especially if we combine PLS-SEM and fsQCA. In first level, we analyze our model. We assess measurement model using PLS-SEM. And then we can get result of, we can get latent variable score from PLS-SEM and use as the input for fsQCA to calibrate this variable and to perform analysis. So if we have higher order, in first step, we need to establish second order. We need to assess second order, and then use the latent variable score of second order for next step for performing fsQCA. So it's possible.
Thank you so much. I think we exceed our time. I would like to ask from you, if is it possible to have your slides? Maybe
slide actually I don't think, but you can watch video in my YouTube channel if you want to.
So we can find the video and there will be all the slides available. Excellent.
Yes. Yeah.
I think if we have time for one more question.
Yes, sure.
Is it fair to say we can perform moderation given the possibility of combinations?
Yeah, I said moderation is possible to perform. We can perform moderation given the possibility of combination. Yeah, I think fsQCA can work very well for moderation because we can compare different sufficient and necessary condition between two groups and see for one group what combination can be sufficient to produce outcome and what happened for second group, for other group. So this can be very good to apply for moderation. I didn't have time to go through, but I wanted to a bit explain about predictive power. Actually, in predictive power, to calculate the predictive power of our model, we need to split our data to two samples. So we perform our analysis fsQCA with one sample, subsample one, and then we identify sufficient and the necessary condition, and then we calculate consistency and coverage for subsample 2 for these sufficient condition. If sufficient conditions are identical between these two subsamples, we can conclude that our model has high predictive power. Actually, this is some sort of out of sample prediction. So also we have in PLS, we have the PLS predict and we use out of sample prediction power and assessment. So we split to two samples to do this power analysis. So for two groups and comparing between two groups and moderation analysis can be an excellent approach to compare.
Thank you so much. Thank you so much for your